Right now, beneath your feet, there's more life than in all the oceans combined. 90% of Earth's bacteria exist underground, living so slowly that a single cell might divide once every 1,000 years. And if simple life can adapt to the deep Earth like that, operating on geological time, breathing stone and feeding on radiation, what else might be down there, living at a speed we're simply too fast to notice? For thousands of years, every major culture on Earth told the same story, that humanity didn't start on the surface, that we came from below. The Hopi people say we emerged from the underworld, guided by beings they call the ant people. The Vedic texts describe 7 layers beneath us, more beautiful than the heavens, filled with architecture and light. The Greeks marked specific caves as doorways to Hades, not metaphors, physical places you could walk into. We've always dismissed these as myths, afterlife stories, symbolic tales about death and rebirth. But what if we got it backwards? What if these weren't stories about where we go when we die, but memories of where we came from when we were alive? Problem/challenge 0, 45-230. Here's the thing, we think we know our planet. We've mapped every continent, every ocean floor, sent probes to Mars and rovers to the edge of the solar system. But when it comes to what's directly beneath us, we've barely scratched the surface, literally. The deepest hole ever drilled was in Russia, the Kola Superdeep borehole, 12 kilometers down. That sounds impressive until you realize Earth's radius is over 6,000 kilometers. We've explored less than 0.2% of the distance to the core. It's like dipping your fingernail into the ocean and declaring you understand the entire sea. And here's what's strange. In that tiny fraction we have examined, we keep finding things that shouldn't be there. Vast underground cities built thousands of years ago, capable of housing tens of thousands of people. Acoustic chambers carved with precision that affects human brain waves. Tunnels and caves that stretch for miles with no clear purpose or origin. Seismic readings showing massive zones of anomalous material at the boundary between the mantle and core. Areas where the laws of physics seem to bend in ways we can't explain. But perhaps the most unsettling discovery of all is the deep biosphere itself. Scientists now estimate that the subsurface contains 90% of all bacterial and archaeal life on Earth. These organisms exist in a state that challenges everything we thought we knew about biology. Some of them are so old, they predate human civilization. They live in pitch darkness, survive on chemical reactions from rocks, and operate on timescales so slow that our entire recorded history would feel like a single heartbeat to them. So if life already thrives down there, in conditions we once thought were completely sterile and dead, what's stopping something more complex from existing in the same space? What's stopping an entire civilization from living beneath us, moving so slowly through time that we simply can't perceive them? Let's start with what the ancients actually said, because when you look closely at these myths, they're far more specific than you'd expect from simple folklore. The Hopi people of the American Southwest have one of the most detailed accounts. They say humanity has lived through 4 worlds. The first world was destroyed by fire, volcanic eruptions, asteroid impacts, something that made the surface uninhabitable through heat and flame. The second world ended in ice, glaciers advancing, temperatures dropping, the kind of climate shift that would wipe out anything living on the surface. And each time the world above became too dangerous, the virtuous were led downward, not upward to heaven, downward, into the earth. They were guided by the ant people, beings with large heads and slender bodies who lived in vast underground cities. These beings taught the Hopi how to store food, how to survive in isolation, how to maintain balance during long periods of darkness. The descriptions are oddly specific. The ant people weren't gods or spirits. They were physical beings with technology and knowledge. They had systems for thermal regulation, for growing food, for managing resources in sealed environments. They understood how to live when the surface became hostile. Now you might think this is just one isolated story, but it's not. The Muskogee Creek people have nearly identical accounts. In the 18th century, a French traveler named Louis Leclerc Milfort recorded their traditions. They pointed to actual caves in the Red River region and said these chambers once housed 15 to 20,000 families. Not individuals, families. These were population centers, underground cities large enough to sustain entire nations. And it's not just North America. Hindu cosmology describes Patala, the underworld, as a physical realm divided into 7 layers. Each layer has its own inhabitants, its own resources, its own characteristics. The lowest level, Nagaloka, is home to the Nagas, serpent people who possess immense wealth and live in cities lit not by the sun, but by glowing jewels embedded in their heads. At first, that sounds purely mythological, serpent people with jeweled heads. But then you learn about triboluminescence. That's the light generated when you break chemical bonds in certain crystals under pressure. Or bioluminescence, which fungi and microorganisms produce in deep caves. If you were an ancient person trying to describe these phenomena, how would you explain it? You might say the inhabitants of the deep earth carry light within themselves. That gems and stones provide illumination in the darkness. The Vedic texts also describe Mayadanava, a master architect in the underworld who built flying cities and structures that defied natural laws. They talk about Hataka, a special kind of gold found in the second layer of Patala, possibly a reference to piezoelectric deposits that generate electricity when compressed. They mention thermal vents and rivers of molten material, knowledge of geological processes that wouldn't be scientifically understood until thousands of years later. And then there's the Greek tradition of katabasis, the descent into the underworld by living mortals. Odysseus, Aeneas, Orpheus, Heracles. These weren't allegories. The Greeks identified actual physical locations as entry points, Lake Avernus near Naples, where volcanic gases killed birds that flew overhead, Cape Tenaran in the Peloponnese, the rivers Acheron and Cocytus in northwest Greece. These were real places you could visit. What's interesting is how the stories changed over time. In early Greek mythology, the underworld wasn't just for the dead. It was the residence of the Titans, divine beings who lived there before they were defeated by the Olympians. Hades and Persephone ruled a functioning kingdom with administration, governance, resources. It was only later, in works like Homer's Odyssey, that the underworld became exclusively a cemetery, a place only for souls. That shift is significant. It suggests an earlier memory of the underworld as a living civilization, which later transformed into a realm of the dead. As if contact was lost. As if the knowledge of who actually lived down there faded into myth, and all that remained was the vague sense that it was important, that it was connected to mortality and transition. Every one of these traditions shares common architectural elements, gates and levels, water systems, governance structures, permanent populations performing specific functions, material challenges requiring adaptation to darkness, altered atmospheric composition, extreme temperatures. This isn't the architecture of pure metaphor. This is the architecture of an actual civilization, described in the only language available to pre-scientific cultures. So why would every culture, separated by oceans and continents, tell the same story about a physical underworld? Why would they all agree that survival during catastrophes meant going down, not up? Why would they describe infrastructure, social systems, and beings who taught them how to live underground? Unless they were all remembering the same thing. Now we have to address the elephant in the room, the hollow earth theory, because that's what most people think of when you mention civilizations inside the planet, and it's been thoroughly debunked. In 1692, the astronomer Edmund Halley proposed that Earth consisted of concentric shells separated by atmospheres, with each shell potentially harboring life. He was trying to explain anomalies in the magnetic field, the way the poles seemed to drift over time. His model wasn't fantasy. It was an attempt to solve real scientific problems with the tools available at the time. But modern physics has made it clear. Earth isn't hollow. Gravity measurements prove the planet has the mass of a solid object. Seismology maps the interior by measuring how waves travel through it after earthquakes. We know there's a crust, a mantle, and a dense iron core. The pressure at those depths would crush any hollow void. So the hollow Earth is dead, but the honeycombed Earth, that's a different story. You see, we now know that Earth's interior isn't uniform. It's not a simple layered sphere like the diagrams in textbooks suggest. The mantle contains vast regions of anomalous material, places where seismic waves slow down dramatically, places where the chemistry is different from the surrounding rock, places where, frankly, we don't fully understand what we're looking at. At the boundary between the mantle and the core, there are structures called ultra-low velocity zones, ULVZs. These are patches, sometimes hundreds of kilometers wide, where seismic waves drop in speed by up to 45%. Scientists think they might be partially molten rock, or iron-rich material leaking from the core, or remnants of ancient tectonic plates that sank down and got stuck. But here's the thing. A study in 2024 found ULVZs in places they weren't supposed to be. Beneath Alaska, beneath Greenland, beneath Central Asia, areas that our models said should be stable, normal mantle. The lead researcher, Thomas Schouten, said something remarkable. He said, "We see these anomalies everywhere in the mantle, but we still don't know what material is creating these patterns. We don't know. Despite all our technology, despite all our measurements, we genuinely don't understand what these zones are or why they're there." Then there are the large, low shear velocity provinces, LLSVPs, two enormous blobs, each the size of a continent, sitting at the core mantle boundary, one beneath Africa, one beneath the Pacific Ocean. They cover about 8% of the entire mantle by volume, and they're chemically distinct from everything around them. The leading theory: they're fragments of Theia, the protoplanet that collided with Earth 4.5 billion years ago to form the Moon. If that's true, then we have pieces of an alien world, literally from another planet embedded deep inside our own. They've been there since before life began, and they're not inert. These blobs drive superplumes that feed volcanic hotspots like Hawaii. They affect the magnetic field. They interact with the core. What's fascinating is that these aren't theoretical constructs. They're observed, measured phenomena. We can see them in the data. We just don't fully understand their composition or how they influence the planet's behavior over geological time. And then there's water. In 2014, scientists discovered ringwoodite, a mineral from the mantle transition zone, trapped inside a diamond. That sample contained 1.5% water by weight. If the entire transition zone has that composition, it holds 3 times the volume of all surface oceans combined. This isn't liquid water. It's hydroxide ions locked inside crystal structures at depths of 400 to 660 kilometers. But the presence of water at those depths changes everything. It means the mantle is a massive reservoir of volatiles. And under the right conditions, local heating or chemical reactions, that water could be released into pockets and fractures, creating environments where chemistry happens, where energy flows, where potentially biology could establish a foothold. We used to think the deep Earth was sterile, a furnace of molten rock where nothing could survive, but the discovery of the deep biosphere shattered that assumption. Life exists at least 5 kilometers into the continental crust, at least 2.5 kilometers below the ocean floor. Microbes have been found in boreholes 3 kilometers deep, living at 60 degrees Celsius in ancient groundwater that hasn't seen the surface in millions of years. And these aren't just a few scattered bacteria. The deep biosphere contains an estimated 15% of the planet's total biomass. 90% of all bacterial and archaeal life exists underground. They survive without sunlight, without organic matter from the surface. They feed on hydrogen produced when water reacts with rock. They metabolize sulfur compounds. They harness energy from radioactive decay. Some of them are so slow that they make glaciers look fast. A single cell might divide once every 1,000 years. They exist in what scientists call a maintenance state, repairing damage, preserving themselves, waiting in a kind of biological stasis that we don't fully comprehend. But here's the critical point. If simple life can do this, if microbes can adapt to the deep earth and thrive in conditions we thought were impossible, then the constraints we put on habitability are wrong. We've been defining life based on surface conditions, based on sunlight and photosynthesis, and the rhythms of day and night. But the deep earth operates on entirely different principles. And if complex life wanted to adapt to those conditions, the building blocks are already there. Extremophiles can survive temperatures up to 120 degrees Celsius. High pressure stabilizes molecules, potentially extending those limits even further. There's energy available from geothermal gradients, from chemical reactions, from natural radioactivity. There's water, carbon, minerals, everything you need. The question isn't whether the deep earth could support life. The question is whether anything complex enough to call a civilization ever figured out how to exploit it. The thing is, we don't have to speculate about whether advanced life could survive underground, because humans already proved it's possible, not in theory, in practice. In Cappadocia, Turkey, there's a city called Derinkuyu. It extends 85 meters beneath the surface, carved entirely into soft volcanic rock. 18 levels of interconnected chambers, tunnels, storage rooms, chapels, wells, and ventilation shafts. At full capacity, it could house 20,000 people, along with their livestock, along with food stores to last for months. The engineering is remarkable. There's a central ventilation shaft that runs 55 meters straight down to the water table, providing both fresh air and access to groundwater. Every level has massive rolling stone doors that weigh 500 kilograms, designed to seal from the inside. If invaders entered, you could lock them out section by section, trapping them in narrow corridors where numbers didn't matter. This wasn't a temporary shelter. This was a fully functional city designed for long-term habitation, and it's not unique. Over 200 similar underground cities have been discovered in Cappadocia. Some are connected by tunnels stretching 9 kilometers. They form a network. Archaeologists aren't entirely sure who built them or when. Some sections date back to the Phrygians, around 700 BCE. Others might be even older. But what's clear is that whoever designed these systems viewed the surface as temporary and dangerous. The underground wasn't a fallback option. It was the primary habitat. And it worked. People lived in Derinkuyu for centuries. They raised families. They maintained social structures. They farmed, they stored food, they governed themselves. The psychological adaptation to permanent darkness, to living beneath tons of rock, to never seeing the sun, that's something humans accomplished thousands of years ago with Bronze Age technology. Now imagine what you could do with modern knowledge, with geothermal power, with LED lighting, with hydroponics and engineered biology. The scale and sustainability would increase exponentially. But humans aren't even the first to master the subsurface. In South Africa, in a cave system called Rising Star, researchers found evidence that Homo naledi, a small-brained hominin species, was deliberately placing their dead in deep chambers 300,000 years ago. These weren't surface burials. These were locations you could only reach by squeezing through pitch-black vertical shafts. And to navigate those depths, Homo naledi must have used controlled fire, torches. There's evidence of soot and hearths in places that natural light never reached, which means that long before Homo sapiens dominated the planet, another branch of the human family had already figured out how to explore and utilize the deep underground. So underground living isn't some distant science fiction concept. It's part of our evolutionary history. We've been doing it for hundreds of thousands of years. But Derinkuyu and Rising Star are just the beginning. There are other sites that are far stranger and far harder to explain. In Zhejiang province, China, there's a complex called the Longyu Caves. 24 massive artificial grottos carved from solid siltstone. Over 1 million cubic meters of rock removed. Every surface, every wall, every ceiling, every pillar covered in uniform parallel chisel marks. The caves date to at least 200 BCE, but here's the mystery. There's no record of their construction in any Chinese historical document, and China was famous for its bureaucratic record-keeping. Every major construction project, every emperor's decree, every significant event was documented in exhaustive detail. But these caves, nothing. No records of who built them. No records of why. No records of how they moved 1 million cubic meters of stone or where that stone went, because there's no debris pile. The caves were rediscovered by accident in 1992 when a local farmer started pumping water out of a pond and found a man-made chamber underneath. The structural integrity is perfect. Despite being flooded for centuries, despite earthquakes, the pillars and ceilings have held without reinforcement. The angles are precise. The spacing is calculated. Whoever designed this understood load-bearing engineering at an advanced level. But there's no purpose we can identify. They're not tombs. They're not storage. They're not temples. They're just there, massive and inexplicable, a ghost of a project that nobody remembers. And then there's the Hypogeum of Hal Saflieni in Malta, an underground temple over 5,000 years old, carved into limestone. It contains multiple chambers, spiral decorations, and something called the Oracle Room. The Oracle Room is acoustically engineered. It has a natural resonance frequency of 110 Hz, and here's where it gets strange. Studies by UCLA and the OTS Foundation found that when people listen to sounds at 110 Hz, it temporarily shuts down the prefrontal cortex, the part of the brain responsible for language and logic. At the same time, it stimulates the right hemisphere, which governs emotion, intuition, and visual processing. In other words, this chamber was designed to alter consciousness, to induce a trance state. The people who built it 5,000 years ago, using stone tools, understood the neurological effects of specific sound frequencies and engineered a space to exploit them. That's not primitive. That's not accidental. That's sophisticated psychoacoustic engineering applied to architecture. These sites and dozens of others like them point to something consistent. Humans, and possibly other hominid species, have not only lived underground but have built massive, precisely engineered structures in the subsurface for purposes we still don't fully understand. So when we ask whether an advanced civilization could exist beneath the surface, the answer is already yes. We've proven it's possible. The only question is how far could it be taken, with enough time, enough resources, enough knowledge. Now we need to talk about something that lives on the edge of mainstream science, the cryptoterrestrial hypothesis. It's the idea that the beings people report seeing, the entities in UFO encounters, the creatures in abduction stories, might not be extraterrestrial. They might be from here, from Earth, but hidden, underground or underwater, or existing in some parallel biosphere we haven't detected yet. The term was popularized by Mac Tunney's in his book The Cryptoterrestrials. His argument was simple but compelling. If aliens were visiting Earth from other star systems, the distances involved are staggering. Even at light speed, the nearest potentially habitable exoplanet is years away. And if they're making the trip regularly, for decades or centuries, showing up in every corner of the globe, the logistics don't make sense. But if they're from here, if they're indigenous to Earth, just hidden in places we don't look, then suddenly the sightings make more sense. They're not traveling from another galaxy. They're traveling from another part of our planet. And here's the thing that makes the hypothesis interesting. The beings described in these encounters, the so-called Greys, have a distinctly humanoid physiology. 2 arms, 2 legs, bilateral symmetry, forward-facing eyes. That body plan didn't evolve independently on another planet. It evolved here, on Earth, over millions of years of evolutionary pressure. If aliens evolved on a completely different world, with different gravity, different atmospheric composition, different evolutionary history, the odds that they'd end up looking even remotely human are astronomically low. But if they evolved on Earth, diverging from the same ancestors we did, then the similarities make sense. Tunnies suggested they might be a sister species of hominid, something that branched off from the human lineage and adapted to a different ecological niche. Large eyes for low-light environments, pale skin from lack of sun exposure, slender bodies suited to confined spaces. These are traits you'd expect in a population that spent millennia living underground or in deep ocean trenches. And if they did that, if they moved into the subsurface during some ancient cataclysm, some event that made the surface uninhabitable, they'd want to stay hidden. Because if we discovered them, if we knew they were down there, vulnerable, with limited resources and a small population, we'd either try to exploit them or eradicate them. So they masquerade as extraterrestrials. They let us believe they're from the stars, powerful and advanced and beyond our reach. It's a strategic deterrent. It keeps us from looking too closely at our own planet. Now, does that mean every UFO sighting is a cryptoterrestrial? No. Most are probably misidentified aircraft, atmospheric phenomena, or outright hoaxes. But the hypothesis offers an explanation for the patterns we see. Why sightings cluster around fault lines and geological anomalies. Why encounters often happen near bodies of water or deep caves. Why the technology described seems to interact with Earth's magnetic field in ways that suggest it was designed for this environment. Researchers like John Keel and Jacques Vallée expanded on this idea with the concept of ultraterrestrials, beings that exist in our space but operate in a different frequency or dimension. They enter our reality through window areas, often associated with magnetic anomalies, geological stress zones, or places where the Earth's crust is thin and fractured. Which, interestingly, aligns with ancient traditions. The Greeks believed certain caves were portals to the underworld. The Hopi said the ant people emerged from specific locations in the ground. The Vedic texts described entry points to Patala, guarded and hidden. Every culture had the same idea, that there were places where the boundary between worlds was thinner, where you could pass from one realm to another. If there is a cryptoterrestrial population, if there are beings living in the deep Earth, operating on timescales and energy systems we don't recognize, then we'd expect to see exactly what we see. Fleeting encounters, unexplained phenomena near geological features, technology that doesn't match our understanding but seems purpose-built for navigating Earth-specific conditions. And we'd expect them to be almost impossible to detect, because they've been evading detection for as long as they've existed. So if there is a civilization beneath us, why haven't we found them? Why is there no smoking gun, no undeniable evidence? The answer is deceptively simple. We've barely looked. The deepest we've drilled is 12 kilometers, the Kola Superdeep borehole in Russia. It took 20 years to reach that depth, and they had to stop because the temperatures and pressures exceeded what their equipment could handle. 12 kilometers sounds impressive until you realize that's not even through the crust in some places. The mantle starts at an average depth of 35 kilometers under continents. The core mantle boundary is at 2,900 kilometers. We've explored 0.2% of the distance to the core. Less than that, actually, when you factor in volume. We've sampled a fraction of the planet's interior. It's like dipping a toothpick into the ocean and saying we've searched for Atlantis. The scale of what we haven't examined is incomprehensible. And even in the areas we have explored, our detection methods are incredibly limited. Seismology works by measuring how waves from earthquakes travel through rock. If the waves speed up or slow down, we infer that the material is denser or less dense. But the resolution degrades with depth. Near the surface, we can detect features the size of a building. At the core mantle boundary, our resolution is hundreds of kilometers. A city, no matter how large, would be invisible. A structure, Even a massive one would create seismic anomalies so subtle they'd vanish into the noise of natural geological variation. We see velocity changes. We see density differences. But we interpret them as compositional variations, as partially molten zones, as chemical layering. We don't interpret them as artificial. Because we're not looking for artificial, our models don't include the possibility of engineered structures, so we don't design experiments to detect them. Gravitationally, the problem is even worse. Earth's gravity is dominated by the planet's overall mass distribution. The pull from the iron core, the density variations in the mantle, the shape of the crust. Any localized gravitational anomaly from subsurface structures would be completely swamped by those larger signals. You couldn't measure it. It would be like trying to detect a pebble in a landslide. Thermally, there's no chance. The core radiates heat at 44 terawatts. That's the entire thermal budget of the planet's interior. If a civilization were using geothermal energy, even at an industrial scale, the heat signature would be lost in that massive background flux. Surface temperature anomalies would be negligible, within the noise of volcanic activity and mantle convection. And electromagnetically, the iron core generates Earth's magnetic field. Any artificial electromagnetic signature from deep structures would be drowned out completely. You wouldn't be able to distinguish it from the natural dynamo operating in the outer core. So detection from the surface is effectively impossible. The only way to know what's down there is to go down there. And we can't. The pressures are too high. The temperatures are too extreme. We don't have the materials or the technology to build machines that could survive, let alone function at those depths. Which means the deep interior is functionally invisible to us. We probe it indirectly, through seismic waves and magnetic fields and gravity measurements, but we're interpreting shadows. We're making guesses based on models, and those models were built without considering the possibility of intelligence. There's another problem, the Silurian hypothesis. It's a thought experiment proposed by NASA climate scientist Gavin Schmidt and astrophysicist Adam Frank. The question is this: if an industrial civilization existed on Earth millions of years ago, would we find evidence of it? And the answer is unsettling, probably not. The Earth's surface is violent. Erosion wears down mountains. Subduction pulls crust into the mantle. Glaciers scour the land. Volcanoes bury entire regions. Over millions of years, almost everything gets recycled. Cities turn to sediment. Metals corrode. Plastics break down. Even radioactive waste would decay or be buried so deep in the geological record that we'd never notice it. The only traces that might survive would be anomalies in the chemical composition of ancient rock layers, spikes in carbon isotopes, unusual concentrations of rare earth elements, synthetic molecules that don't occur naturally. But if you weren't specifically looking for those signatures, if you didn't expect to find them, you'd misinterpret them as natural processes. And here's the key point. If a civilization moved underground, if they abandoned the surface entirely and adapted to the subsurface environment, their footprint would be even smaller. No sprawling cities, no roads, no agriculture, no deforestation. Just a few entry points, carefully hidden, and everything else sealed away in stable geological formations kilometers below. You could have an entire nation living in the mantle, and from the surface you'd see nothing. No buildings, no lights, no emissions, just rock and stone and the faint, ambiguous seismic echoes of processes we don't fully understand. So the absence of evidence doesn't mean absence of existence. It means we're not equipped to look in the right places, with the right tools, for the right signatures. We scan the stars for radio signals, hopping to find intelligent life light years away. But we ignore the lithosphere. We don't listen for acoustic patterns in seismic data. We don't analyze thermal anomalies for geometric regularity. We don't search the deep earth for technosignatures. Because we've already decided there's nothing there. Let's assume just for a moment that something is down there, some form of complex life or even intelligence. What would it look like? How would it function? The key is time. Deep Earth life doesn't operate on human timescales. It operates on geological timescales. We know this because we've observed it. The bacteria in the deep biosphere, the microbes living kilometers beneath the surface, they're slow, unimaginably slow. A single cell might take 1,000 years to divide. Their metabolic rate is 1,000,000 times slower than surface organisms. They're not dead. They're not dormant. They're alive, functioning, repairing damage, maintaining themselves. But they're doing it in a state we have no reference for. A kind of biological slow motion where entire human lifetimes pass in what to them might feel like a heartbeat. Now imagine something more complex adapted to that rhythm. Not bacteria, but something multicellular. Something with structure, organization, maybe even cognition. What would that look like? It would be energy-dense but matter-light. It wouldn't need large populations or sprawling infrastructure. It would use geothermal energy, tapping into the heat of the core. It would harness piezoelectricity, the electric charge generated when quartz crystals are compressed by tectonic stress. It would farm radiotrophic organisms, fungi that convert gamma radiation into chemical energy, the same way we farm crops in sunlight. These are real energy sources. They exist in the deep Earth right now. Geothermal gradients provide a constant, limitless supply of heat. Quartz is one of the most abundant minerals in the crust, and under pressure, it generates voltage. Natural radioactive decay from uranium and thorium deposits produces more than enough radiation to sustain radiotrophy. If you wanted to build a civilization without sunlight, without access to the surface, those would be your options, and they're all viable. But the real advantage of living in the deep Earth isn't energy, it's stability. The surface is chaos. Ice ages, asteroid impacts, supervolcanic eruptions, solar flares, magnetic pole reversals. Every few million years, something catastrophic happens that wipes out most life on the surface. But the deep Earth, it's insulated, protected. The temperature fluctuations are minimal. The pressure is constant. The chemical environment is stable. If you wanted to survive long-term to avoid extinction-level events, the subsurface is the safest place in the solar system. And if you're living on geological timescales, if your biology operates slowly enough, you could ride out any surface catastrophe. A nuclear war, you'd barely notice. A supervolcano, wait a few millennia for the ash to settle. An ice age, the temperature a few kilometers down doesn't change. You'd be patient, you'd be durable, you'd outlast everything. But you'd also be invisible, because to us, moving at human speeds, you'd look like rock, like inert geology. We'd measure you with seismology and see a velocity anomaly. We'd sample your structures and think they were natural mineral formations. We'd detect your energy use and attribute it to geothermal activity. We wouldn't recognize you as alive because life to us means movement, growth, metabolism at rates we can perceive. But in the deep Earth, life is slow, silent, still. And maybe that's the answer to the Fermi paradox. Not that intelligent life is rare, but that it's slow. That advanced civilizations eventually realize the surface is too dangerous, too volatile, and they move inward. Into the crust, the mantle, the stable zones where they can exist for billions of years without disruption. They're not broadcasting radio signals. They're not expanding across star systems. They're quiet, patient, waiting. And we'd never find them because we're too fast, too loud, too brief to notice. There are phenomena we can't explain. Things that happen at the boundary between the known and the unknown, where geology and biology and physics start to blur. Take the Taos hum. It started in the early 1990s in Taos, New Mexico. Residents reported hearing a persistent low-frequency sound, somewhere between 30 and 80 hertz. Not everyone could hear it, only about 2% of the population. But for those who could, it was maddening. It wasn't tinnitus. When people left the area, the sound stopped. When they returned, it came back. So it was environmental, not internal. Investigations found elevated electromagnetic fields during the phenomenon, but no clear acoustic source, no industrial equipment, no underground pipes or resonating structures that could explain it, and it wasn't isolated to Taos. Similar hums have been reported in Windsor, Ontario, Brisbane, Australia, Bristol, UK, dozens of locations around the world. The conventional explanations range from seismic activity to very low-frequency radio waves interacting with the inner ear, but none of them fully account for the geographic specificity, the consistency, or the fact that it affects only certain people. If you wanted to communicate with the surface, if you existed in the subsurface and wanted to send signals that wouldn't be immediately obvious, low-frequency sound would be ideal. It travels through rock efficiently. It's difficult to pinpoint, and it's at the edge of human perception, where most people wouldn't notice but a few sensitive individuals might. Is that what the Taos hum is? Probably not, but it's an anomaly, and anomalies are interesting because they represent gaps in our understanding, places where the models don't work. Then there's the strange behavior of seismic waves in the deep mantle. Recent studies have found evidence of small-scale scatterers, structures that deflect and scatter seismic waves in ways that don't match natural rock formations. These scatterers are distributed globally, but we don't know what they are. They're too small to be mapped directly, but their effects show up in the data. One researcher described them as ubiquitous. Everywhere you look, you find them, but they don't fit the patterns we'd expect from mantle convection or chemical layering. They're irregular, almost random, or organized in ways we don't recognize as organized. And then there are the thermal anomalies. In 2025, geophysicists discovered a massive heat blob beneath the eastern United States. It's 200 miles wide and 125 miles deep, an upwelling of hot mantle material in a region that should be geologically stable. The eastern U.S. is an old, quiet craton. It hasn't seen volcanic activity in millions of years. There's no reason for this thermal structure to exist, but it's there, distorting the expected heat flow, creating a localized hot zone in a place where everything should be cold and inert. Again, the explanation is probably natural. Convection, maybe. Some quirk of mantle dynamics we don't fully understand. But it's another example of the deep earth not behaving the way we think it should. These anomalies, the hums, the seismic scattering, the thermal blobs, they might all be natural. Probably are. But they're reminders that the subsurface is full of processes we don't understand. And when you don't understand something, you can't rule out alternative explanations. If a civilization existed below us, using geothermal energy, building structures in the mantle, operating technologies we don't recognize, the signatures might look exactly like this. Ambiguous, just at the edge of measurement. Easy to dismiss as natural because we have no framework for interpreting them as artificial. We see what we expect to see, and we expect geology, so that's what we see. Here's something most people don't think about. We're not strangers to the underground. We've been using it for survival, for shelter, for refuge, since before we were even Homo sapiens. Homo naledi, 300,000 years ago, navigating pitch-black caves with fire, placing their dead in deep chambers. Neanderthals, using limestone caves in Europe for shelter, painting on the walls, living in spaces where sunlight never reached. Early Homo sapiens in Africa, sheltering in rock overhangs during droughts, using caves to escape the heat. The underground has always been part of our survival strategy. It's not alien to us. It's familiar, ancestral. And then, as civilizations developed, we kept building down. The catacombs of Rome, the underground cities of Cappadocia, the Maltese Hypogeum, the Longyu caves. Every culture that reached a certain level of sophistication started carving into the earth, creating permanent structures, infrastructure, entire communities beneath the surface. Why? Because it's safer, because it's more stable, because when the surface becomes hostile, when wars break out, when climates shift, when disasters strike, the underground offers protection. During Kuyu wasn't built for fun. It was built for survival, and it worked. People lived there for generations, raising children who never saw the sun, who grew up in tunnels and chambers lit by torches and oil lamps, and they thrived. So when we talk about the possibility of an advanced civilization existing in the deep earth, we're not talking about something impossible. We're talking about something we've already done, just taken further, scaled up, optimized. What if, at some point in the distant past, a human population or a sister species decided not to return to the surface? What if they found the underground so secure, so resource-rich, that they chose to stay, to adapt, to develop technologies that made subsurface living not just possible but preferable? Over thousands of years, their biology would change, eyes growing larger to adapt to low light, skin losing pigmentation, metabolic rates slowing to match the energy constraints of their environment. They'd become something new, something post-human or parahuman, adapted to a niche we abandoned. And they'd be invisible to us, because they'd be doing what they've always done, living quietly, efficiently in the spaces between the rock, using energy sources we overlook, operating on timescales we don't perceive. We returned to the surface. We chose sunlight and open skies and the volatility of weather and seasons. But what if they didn't? What if they stayed, content in the darkness, and continued evolving while we built cities and fought wars and invented agriculture and technology? By now, they'd be as different from us as we are from Homo erectus. Not alien, but not human either. A divergent branch, a hidden lineage. And they'd have no reason to contact us. We're noisy, destructive, unpredictable. From their perspective, we might be the dangerous ones, the ones to avoid. So they'd stay hidden, deep, patient, watching maybe from the places where the crust is thin, where sensors could listen to the vibrations of our machines, the electromagnetic noise of our cities, learning about us, but never revealing themselves. Because why would they? Let's bring it all together. The myths, the geology, the biology, the archaeology, the anomalies. What does it all suggest? It suggests that Earth's interior is not what we think it is. It's not a uniform, sterile ball of rock and metal. It's complex, dynamic, layered, full of regions we don't understand, chemistry we haven't mapped, processes we haven't observed. The deep biosphere proves that life exists down there. Not just survives, thrives. 90% of all bacterial life is underground, living in conditions we thought were impossible. And if simple life can do it, if microbes can adapt to high pressure, high temperature, no sunlight, then the constraints we place on habitability are arbitrary. They're based on surface experience, not fundamental limits. The geological anomalies, the ULVZs, the LLSVPs, the hydrous transition zone, they prove that the mantle contains vast, stable, energy-rich environments. Places where conditions are not only habitable but potentially ideal for a civilization that wanted to avoid the chaos of the surface. The archaeological sites during Kuyu Longyu, the hypogeum, they prove that humans have not only lived underground but have engineered massive, sophisticated structures in the subsurface for purposes we still don't fully grasp. We've been doing this for thousands of years. We know it works. The myths, the Hopi, the Vedic, the Greek, the Muskogee, they all say the same thing. That humanity came from below. That there were beings who lived in the underworld, who helped us, who taught us, who existed in parallel to the surface world. And these weren't abstract allegories. They described physical places, infrastructure, governance, the architecture of civilization. And the phenomena we can't explain, the hums, the seismic scattering, the thermal anomalies, they suggest that something is happening in the deep earth that doesn't fit our models. Processes we don't understand. Patterns that look almost organized, almost artificial if you're willing to consider that possibility. None of this is proof, but it's a convergence, a pattern, and patterns mean something. The hollow Earth is dead. Physics killed it. But the honeycombed Earth, the idea that the lithosphere and upper mantle contain vast, stable, habitable voids, chemically distinct provinces, ancient refugia, that's not only possible, it's probable. The data supports it. And if you wanted to hide a civilization, the deep Earth is the perfect place. It's thermally invisible, gravitationally indistinguishable, seismically ambiguous. You'd be surrounded by kilometers of rock, insulated from surface detection, operating on energy systems we don't monitor and timescales we don't perceive. You'd be the ultimate crypto-terrestrial, indigenous to Earth but hidden, not in another dimension, not on another planet, just down, beneath the crust, in the mantle, in the spaces where the geology is strange and the seismic waves slow down and we don't have the tools or the resolution to see clearly. And maybe that's been the case for millions of years. Maybe there's a lineage down there, a branch of life that diverged long ago and chose the deep over the surface. A civilization that operates on geological time, patient and slow, watching the surface world churn through ice ages and extinctions and the brief flicker of human history. They'd see us the way we see mayflies, fast, frantic, short-lived. We build cities and they crumble. We wage wars and they end. We think we're the pinnacle of evolution, but to them, we're just surface noise. Temporary residents in the thin skin of a planet they've inhabited since before we existed. And we'd never know, because they're not moving at our speed. They're not broadcasting at our frequencies. They're just there in the depths doing what they've always done. Living. We've spent centuries looking up, scanning the stars for signals, building telescopes to peer into distant galaxies, searching for intelligent life somewhere out there in the vast emptiness of space. But we've ignored what's beneath us, the deepest ocean trenches, where life exists at pressures that would crush steel, the subterranean biosphere, where bacteria live for millennia in solid rock, the mantle, where seismic waves behave in ways we don't understand and massive structures sit at the core boundary, chemically distinct, possibly older than the continents themselves. We've drilled 12 kilometers down and declared we understand the planet. We've looked at myths about the underworld and called them allegories for death. We've seen underground cities and said, humans built those for temporary shelter, and moved on. But what if we're wrong? What if the ancients were trying to tell us something literal, not metaphorical? What if the Hopi ant people were real? What if the Nagas of Hindu cosmology, the beings with jeweled heads living in cities lit by bioluminescence, what if they existed? What if the Greeks marked entry points to a physical underworld because those places actually led somewhere? What if during Kuyu and Longyu and the Hypogeum weren't exceptions, but examples? Proof of concept. Evidence that humanity has always known how to live below, and that we've done it successfully for as long as we've been human. And what if the deep biosphere, with its slow, patient, nearly immortal microbes, is just the beginning? What if complex life adapted the same way, slowing down, sinking deep, becoming something we don't recognize as life because it operates outside our frame of reference? We're moving too fast. We live 70, 80, maybe 90 years. We build and destroy and rebuild in decades. We measure time in seconds and hours and days. But the Earth measures time in millennia, in epochs, in the slow grinding of tectonic plates and the rise and fall of mountain ranges. And if there's something down there living at that speed, we'd never see it. We'd walk over it every day, drive cars over its ceiling, build cities on its roof, and never know. Because we're not looking. We're too busy scanning the stars, hopping to find someone out there who might be like us. But maybe they're not out there. Maybe they're in here, deep in the rock and the darkness and the slow, silent patience of the Earth itself. We call ourselves the dominant species, the intelligent life, the the civilization. But what if we're not? What if we're just the surface noise? The fast, loud, temporary inhabitants of a thin layer of a planet that has secrets we've never imagined, in depths we've never reached, living on timescales we can't comprehend. What if the real civilization, the old civilization, the one that's been here longer than we have, is down below, moving slowly, thinking slowly, living in a world we've never seen and never will because we're too fast, too brief, too blind to notice? And what if that's exactly how they want it? The Earth is more alive than we are, and it's living in slow motion. If this made you think differently about what's beneath us, you'll want to watch what happens when we explore the deep ocean and find things that shouldn't exist there either.